Okay, in this screencast I want to look at the numerical methods for estimating area. As you know, we're able to find exact areas of functions bound by curves, or areas bound by curves by using integration, and by integrating the function that is the graph of which is one of our boundaries. I'm going to use an equation here, a function that we can integrate, but the point of these actually is that why would you estimate when you can find exact? You know, integration gives us exact areas, but the point is you can't integrate every function. Now, I can give you a log function, I'll give you an exponential function, I'll give you loads of functions that we don't have an integration technique for. You know, and they're not polynomial ones, fine, but they represent a small percentage of the total number of functions that exist. So for some functions that we don't have an integration technique for, we're going to need to estimate areas. So let's say I'm going to use a quarter x squared plus 1, one that we can integrate, because I want to compare the exact answers with the so I'm looking for this area. I want to find the exact area, see how good our estimates are. So let's go and find the exact area. I'll do this quite quickly. So we're looking at this area in here between 4 and 0. It's all this stuff here, and bound by a quarter x squared plus 1. The x-axis here, x equals 4 and x equals 1, x equals 0. So how's that done? It's done in such a way. So I'm going to, as I say, I'll do this quickly because we've been through a lot of this stuff and you know how it's done. We're going to integrate that, aren't we, between, so up the power by 1, divide by 3, okay, and we're going between 4 and 0, and we sub 4 in, we get 64 over 12, plus 4 in there. 4 is 48 over 12, and then we subtract 0. So I get 64 plus 48, which is 100, and 12 over 12, which goes to 28 over 3, right? Which is equal to 9 and 1/3. I'm going to put it as a mixed number there because it will make it easier to compare. Right, that's the exact area there. Right, let's make out. This is a function we can't integrate, so we're going to have to estimate it. Okay, well, this is how we go about it. Firstly, what we do is we split. Right, what we do is we split the interval from 4 to 0. We split it into, I don't know, I'm going to just split it into single units. So we've got 1, 2, 3, 4. So I'm going to split it like that. I'm going to draw lines up here. So I'm splitting it up and making it so that I can make lots of different shapes out of it and do an estimate that way. Okay, so I could have done it, in 8 strips. I'm doing it in 4 strips between 4 and 0. So the height of each one is 1 unit. Now there's different methods we can use. The first one I'm going to have a look at is called the left endpoint estimate. Okay, so this was exact here. Now we're going to go for left endpoint estimate, because what I'm going to do here is, in this technique, we're going to use rectangles. It's a pretty crude way of doing it, but I'm going to use rectangles. And so what I'm going to do is I'm going to use the left end point of each rectangle. Right, there's 1 rectangle, 2, 3, 4. I'm going to use this left end point to do an estimate. Right, now I'm still picking out my choice of pen color. So what that means is I'll come across here like that, and that there will be my rectangle 1, and rectangle 2, I'm going to use my left post of 1 to go across here and create another rectangle there. I'm going to find the area of that, because rectangles, they're no issue for me. I can work out the area of rectangles. Okay, so the left endpoint estimate is this rectangle here, using the left endpoint. So I need my function value at 0. Okay, that's my function value at 0 is 1. So this is 1 by 1. So my first rectangle is a 1 by 1. My second rectangle, I need to know, see, I'm going up here from 1 to the curve. That's the height of my rectangle. So I put 1 in here. I get 1 squared is 1 1/4 plus 1. That's 5 quarters. 5 quarters times 1. They're all times 1. Okay, my third one goes up here and across, doesn't it? Right, now I've missed out badly here. This is not a great estimate at all. But it's that one there. It's my function value at 2. I'd square 2, I get 4. A quarter of 4 is 1. So that height there is 2. And yeah, it's 2 by 1 again. And my left post estimate there gets me across from 3. So I go up to 3. 3 squared is 9. 9 quarters plus 1 is 13 quarters. Again, times 1. So this is my left endpoint estimate. See, I've just summed 4 rectangles up. 1, so I've got 4 over 4 plus 5 over 4 plus 8 over 4 plus 13 over 4. Put that all over 4, and I've got 9, 30 over 4, which is equal to, what's that equal to? 7.5 units squared. So 7.5, it's not surprising. It's below 9 1/3. It's not a great estimate. It's quite a way off. It's about 20% off. It's because of all these bits in here. Okay, and now I'm going to use a right endpoint estimate. Wow. Yeah, we need to go through all this. Right endpoint estimate. So what's that going to be? Because what I could have done is I could have actually drawn rectangles above, couldn't I? So if I use this as my height, now I'm going across there, and I'm using that rectangle as my estimate. Right, and for the second rectangle, for this one here, I'm using that as my estimate there, all that. So now I'm above the curve, This is going to be an overestimate now. So, how does it look? We go. A right endpoint, I'm using 1 rather than 0, aren't I? 1 as my function, as my x value. I put that in up here, 1 squared is 1, so that's 5. I've already calculated that, that's 5 over 4. Again, that's times 1. I'm not going to put times 1 each time this time. My right endpoint, so 2 goes up. I've worked out what 2 is. It's 2 squared is 4. Quarter of 4 is 1. That's 2. So that's 2 by 1. Now I go to 3. 3 is my, so I'm using that as my rectangle, right? So that's the height of it is 3 squared 9. A quarter of 9 is 9 over 4. Plus 1 is 13 over 4. It's 13 over 4 by 1. And my last one here is going to be way off. Look at that. That's my rectangle there. So that goes up 4. 4 squared is 16. Quarter of 16 is 4. That's 5 high. 5 by 1 is my last rectangle. So I've got 4 rectangles. They're the areas of them. And they're my right endpoint estimates. So now I've got 5 over 4 plus 8 over 4 plus 13 over 4 plus 20 over 4. I put them all over 4 if you see what I'm doing there. 5, 13, 26, that's 56 over 4. 56 over 4, is that right? 5, 13, no, it's not right, it's 46 over 4, I'm sorry. Little error in addition there, 46 over 4, which gets me 23 over 2, which is 11.5 units squared. Look at that, 11.5. 7.5 underneath on my left point estimate, and my right point estimate, 11.5. So you would then assume, okay, it's somewhere in between the two, because one's an underscore, and the other, in this case the right, is an overshoot. So this one's under, this one's over. You're going to go, well, it's between the two, and that's the. I'm estimating, so that's going to have to do. It's not great, but it's better than nothing. Okay, but the best estimate is to come, and that's using trapeziums. Look at this. So here I go. There's a lot of traffic on here now. But if you see this, what I'm going to do now is I'm going to draw a line from here to here and make a trapezium out of each one. From this point here to this, I'm going to draw a straight line. And the more trapeziums I use, actually, the closer it's going to actually be. Look at that. They're almost bang on, aren't they? So I'm going to use trapeziums. So I'm going to use 4 trapeziums to estimate it now. Now, this is called the trapezoidal estimate. The trapezoidal estimate. All right, let's have a look at it. Trapezoidal estimate. Now, let's just recap what a trapezium, the area of a trapezium is. It's a half by the height by A plus B. A and B are the parallel sides. Okay, so in this case, my height is always 1. Right, so in this case, right, this is my trapezium here. If this is my trapezium, giving it to you in the orientation that you've got up there. These are my parallel sides, so these are my x lines, and this is my height here. So that's h, this is A and this is B. So we get our heights from our function values. Okay, so this first one is going to be, my trapezoidal estimate is a half by A plus B. My A is this value here, which is 1, plus function value at 1, which is, put 1 in there, it's 5 over 4. 1 plus 5 over 4. Right, now it's a half. My second trapezium is a half of the height, which is 1, so this is a half. Now my A and B in this occasion are this point, this and this, these distances. So at x equals 1, it's 9, or what do you say that was? It's 5 over 4, and at x equals 2, it's 2 squared is 4, it's 2. So it'll be 5 over 4 plus 2. I've got 2 more trapezia to look at. Now, we see we double up on this one, don't we? So we always use one of the endpoints twice, except for the first and the last. So it's a half by 2 plus, put 3 in now, because that's my other value. That's my B. 3 squared is 9. 9 over 4 plus 4 over 13 over 4. And the last one goes, again, it's a 13 over 4. Now we put the 4 in, we get 4 squared, 16, 5. So it'll be 13 over 4 plus 5. And you see what happens here actually is that we end up with a half by 1 plus 5 plus twice the rest of them, because the half by 5 quarters. Hang on a sec. Okay, to simplify this calculation, if you have a look at what we've got, a half by 1 and a half by 5 on 4 plus a half by 5 on 4 plus a half by 2 plus a half by 2. So you can see that each of the halves are being done by 1, 5, which are the so is that and that the first and the last function values. The half's being done by them once, but it's being done by the 5 on 4 and the 2 and the 13 on 4. It's been done twice. See, the half by 5 on 4, that one there and there, and then the half by 2 is there and there. So we're getting 2 of those. So it's 2 times a half of the rest of them. 5 over 4 plus 2 plus 13 on 4. Alright, so that's just going to simplify our half by 1 plus 5 is 3, a half of 6 is 3, 2 times a half is 1, so now we've got 5 on 4 plus 8 on 4, which is 13 on 4, so that's 26 on 4, 3, that's 12 on 4, it's 38 over 4, which is equal to 19 over 2, which is equal to 9.5 units squared. 9.5 units squared, our best estimate yet. 9 1/3 is what we know to be exact. And there's our left and right endpoint estimates. Okay, so using rectangles for the left and right endpoints, using trapeziums, our best estimate is with trapeziums. We need to be able to use all those estimating methods. I'm going to close it there. This is our last exercise for the year before we get into some revision for the yearly exams. We're looking at exercise 23E, starting page 661, and we'll have a day or two in class working all that stuff through. Okay, so I'll see you then.